Okay, these are going to be, we're going to go over the day 1 homework. So take out your day 1 homework and we'll go over the answers. In the first part, we're going to change each of the following to logarithmic form. The 4 given to an exponential form. Don't forget that log base b raised to some exponent is equal to a number, so it means b to a number is equal to that answer. So you want to make sure that we know how to go back and forth between the log form and the exponential form. Letter A, that means that x is equal to log base a to get y. And letter C, 3/2 is the exponent is equal to log base 9 to get 27. You can also write it this way, like I did for letters B and D. Log base 3 to get 81 is equal to 4. 4 is the exponent. Letter D, log. And again, I didn't write the number 10 because I don't have to. If the base is 10, we don't have to write it. It's understood to be 10. 0.01 is equal to -2. The other direction, we're going to change each log form to exponential form. 3 is raised to the second power to equal 9. These are a little bit easier, especially if the numbers make sense. Letter C, 27 is raised to the 2/3 power to get 9. Letter B, r to the t is equal to s. And then letter D, 1/8 raised to the -1/3 power is equal to 2. Number 3, A through D, A through H, we're supposed to evaluate each expression, change the form first. Notice that none of them, they didn't have x set equal to x. Some of you can do this off the top of your head. 2 to the what power is equal to 8, so it's 2 to the 3rd, x is equal to 3. Or some of us may have to rewrite it in exponential form to get what we're looking for. We're looking for the exponent to which 4 is raised to get 64, which is also 3. A little bit of a pattern here. 10 to the what power is equal to 1,000. That's also 3. Letter D, 3 to the what power will give us 1/3, and x equals -1. E through H, a little bit more complicated because we've got some negatives in here we have to deal with because we've got some reciprocals. Letter E, 27 to the what power gives you 1/9. Remember from last chapter, we want to change them to be equivalent bases, 27 and 1/9, both using base 3. 3 to the 3x is equal to 3 to the -2. Set your exponents equal to each other. X is equal to -2/3. Letter F, 1/5 to the x power is equal to 125. And then again, you rewrite them using common bases. Letter G, 10 to the x is equal to 1/10,000. That one some of you could have done just by moving the decimal point over. X equals -4. And then letter H, 8 to the what power is equal to 32. And again, rewriting both 8 and 32 with a common base of 2. 32 is 2 to the 5th. 8 is 2 to the 3rd, 2 to the 3x. And then set the exponents equal to each other. X is equal to 5/3. Number 4, x is given to us, labeled here for us. Letter A, we're looking for 2 to the 4th power, which is 16. Letter B, we're looking for the base. What is it that we raised to the second power to get 16? And x is equal to 4. Here, what is the answer? 6 to the -6th power. Ask the calculator. 6 to the -6 is 1/46,656. Okay. On the back, more of setting them up. For letter D, 2 squared is equal to x squared minus 2x plus 5. And then set equal to 0, solve for x. X is equal to 1. So again, changing it to exponential form. Your base is here, raised to the exponent, gives us this answer. Letter E, same thing. 3 is the base, raised to the second power is equal to x minus 2. Solve for x. Letter F, 4 squared is equal to 3x plus 1. Solve for x. And letter G, x plus 1 to the 3rd power is equal to 27. Make sure you take the cube root of both sides, raise both sides to the 1/3 power, subtract 1, x is equal to 2. 5 and 6, number 5, I've got x is equal to 3 because I'm looking for log base 4 to get 64, meaning to what power should I raise 4 to get 64, which is 3. Number 6, 2 to the what power is radical 2, and that's going to be 1/2, 2 to the 1/2 power. And actually this should have been 2 to the 1/2 power is equal to 1/2. There we go. X is equal to 1/2, right? No, radical 2. That's wrong, 2. This should be radical 2. There we go. And then number 7, x is equal to 0 because we are looking for the exponent to which we're going to raise 3 to get 1. And then number 8, notice the base is not given to us, so we understand the base is 10. 10 to the what power is 100, and that is 2. You need to know stuff about the graphs of the log functions. Left 10, down 4. Moving at left 10 is the x plus 10, and then minus 4 is down 4. Describe the transformation. Make sure that your horizontal gets done first to the right 3, then the steepness, and then up 2. The x-intercept, x is equal to 4, by setting y equal to 0 and solving for x. Don't forget this is going to be 6 to the 0 power is equal to x minus 3. 6 is your base, 0 is the exponent, and x minus 3 is the answer. Anything raised to the 0 power is always 1. X minus 3 is equal to 1. X equals 4. You had 2 graphing questions to do on the next page for homework. Letter A, we wanted to graph log base 4x, and it's the black graph here, g of x. And then log base 4x minus 5. Everything got shifted to the right 5. Make sure you remember to shift the asymptote, shift the x-intercept first, and then bring your points over, connect the dots as well as you can for accuracy. And then number 13 asks us to graph 3 to the x, which is in black here, 3 to the x. And then the inverse is going to be 3 to the y is equal to x, otherwise known as the log function. Log base 3x is equal to y. And again, it's a reflection over the line y is equal to x, with this time an x-intercept at 1, 0. And then the last question is just a review from last chapter. In 10 years, the number of deer should go down from 5,000 to 3,324. Please pass this in to the substitute, which I will, at that point, when I get them, I will grade them. Give yourself a grade using the red pens that you have, just like always. Pass them in, make sure that your initials or your name is on the second page in case it gets separated.